Okay, so welcome everyone to what is going to be our third and final chapter on statistics, which is to do with presenting our data. Okay, so we're going to just revise a little bit on what you would have done either in first or second year there in terms of line plots and also in bar charts, first of all. So that's just a nice, easy intro into it here. So if we just have a look at, it's page 297 in our books, all right. But if we just have a look at what we were talking about, a line plot, all right. Generally, it's simply we're talking about a straight line. In this case, temperature is the point of reference in this, and each dot represents a particular recording of the temperature. So if we look up, say, are we given the month? So we're talking about temperatures in Barcelona during the month of June, all right, and they're given out here up at the top, and then we had to take and create this line plot. So all about presenting our data in Stats 3 will be given the information, and we will have to present it graphically. All right. So if we look at here, 30 degrees Celsius. All right. There was one day in that month of June where 30 degrees was recorded. If we look down here, there was 2 days that 24 degrees was recorded, and so on and so forth. All right, and we can see that the max temperature in June was 31 degrees and the minimum temperature was 19 degrees. They have a little arrow then outlining that this 19 degrees is an outlier, and you can see it is very much on its own in comparison with the rest of the data. All right, so it's out there on its own. So generally, a definition of an outlier or an extreme value is a data entry that is very much away from the vast majority of the data that has been collected. All right, so there's nothing really difficult about a line plot, so I'm not going to go in and compile any of those. They are fairly self-explanatory. You're simply putting a dot, nice ordered, maybe have a light line done with a pencil and a ruler, and then include a dot in these here so that it's nice and structured. All right, but line plots, fairly straightforward there. Okay. Moving on then to the next section here, which we're talking about is our bar charts. Okay, so we're generally going to be given 2 axes, all right, and generally it's going to be a measure of something and also the frequency that event has happened. So in this case, they're dealing about numbers. So I don't know what, potentially it could be shoe sizes here, all right, in a class, and then this is the frequency that shoe size occurs. All right, what are we talking about here? So this is actually the number of text messages and the frequency of text. So I'm guessing they're going to, so the bar chart below shows the number of text messages received by a group of students on a particular Saturday. So there's a time frame given, it's on a Saturday, and we're told that it's a number of students getting them. All right, so if we look at here, so the number of text messages received, so 4 messages received. Well, if we come across here horizontally, we can see that, well, 6 students received 4 messages on that particular day. If we look at, say, well, how many students received 9 messages? Well, coming across here, we're talking about 9 students received 8 messages. Okay, so that's how you're going to be able to read off your axes, your X and your Y axis. You have to label them. Generally, your Y axis, you're talking about the frequency of the event happening, and then whatever we're discussing, in this case, text messages, but it could be anything, it could be the likes of what we said earlier, shoe size. Okay. What can we be asked if we were just given that diagram there? You might be asked, well, how many students were surveyed? Okay, so it might be a particular class. How many people were surveyed? Well, from our bar chart, this is the frequency. So if we look at here, 1 student received 1 message. All right, 2 students received 2 messages. All right, so far we have 3 students in total. So you're just looking at the frequency of each message recorded and adding the frequency together to get the total number of students. And you can see here, that's what they've done here. And there's a total of 60 students were surveyed for this particular section. All right. Say if we wanted to work out a percentage. So what percentage, say, of students received 4 text messages on that particular Saturday? Well, there was 6 students in total, all right, received 4 messages, out of a total of 60 students. So percentage, we're going to put the 6 all over 60, reduce that down, that's going to be, if you look at what's the common denominator between 6 and 60, well, it's 10, so it's a tenth or 10%. Okay, and that's really generally all you're kind of going to be asked for. You're either going to have to enter the data and create a bar chart, or you'll be given a bar chart and you will have to take and read off of it. Okay, so that's the main two points that we'll discuss. So I might do one of them for us here. We'll just have I haven't even read it, but we'll have a look and we'll have a go at question 4 for E. So we'll just highlight it here and copy and paste it. So add a new layer and bring this in. All right, so we'll just have a go out doing this question here now. All right, so this bar shows the number of pictures remembered by each student in a memory experiment. So how many students took part in the experiment? What is the modal number of pictures remembered? How many students remembered less than 7? And what is the range of the numbers of pictures remembered? Okay, so if we move out over here, so for part 1, all right, we'll reduce down that side of the biro. Okay, how many students took part in this experiment? Well, along your x-axis here, along the bottom, is the number of pictures. This is the frequency. So we're just adding the frequency up of each of the various different pictures. So we've got 1 and 2 is 3, 3 and 4 is 7, 7 and 5 is 12, 12 and 6, 18, 18 and 7 is 25. So there was 25 students. Are we talking about students? Yeah, students. Okay. What is the modal number of pictures remembered, right? What is the mode, right? Mode from earlier on in stats 2, we found was the most often occurring data entry. Well, we can see here the frequency, the highest frequency will be the one that occurs most. And you can see here that 10 here has the highest frequency. So 10 pictures is the modal number of pictures. So 10 pictures. Now that's a U and an R together. Just, we might add it in if we can, a little bit neater. All right. Part 3 then, how many students remembered less than 7 pictures? So less than 7 pictures. So 4 students remembered 7. How many students remembered less than 7? Well, it is just the 5 and the 6 here. So 1 and 2 is 3. So 3 students. And part 4 then is, what is the range of the number of pictures remembered? Well, the range, what we found again from stats 2, was the difference between the smallest and the biggest. So what is the range of the number of pictures remembered? Well, one student only remembered 5 pictures, where 7 students remembered 10. All right, so the range, the highest value is 10, the lowest value is 5, so it will be 10 minus 5, which is equal to 5, which is our range. Okay, and that's basically given a bar chart and asked to pull information from what you're seeing there in the bar chart. Okay. Again, it's pretty much similar for when we're talking about line plots. Okay, so just before we go on to pie charts, all right, the next section here, if we look, sometimes we can have groups of data put together, okay? So in this case, they've data collected and they've separated by gender. So they've separated it between male and female, all right? And that's going to give you a little bit more insight into the opinions and maybe the breakdown between gender So a group of 20 males and 20 female teenagers were asked their opinion on whether physical education should be compulsory. All right. So the views may change in respect to gender. All right. But that's one way. If you're looking, okay, geez, I've never seen when two bars are slap up tight against each other without a space. Okay, that's maybe why you're including, or it could be, say, before an experiment and after an experiment or something like that. All right, but remembering our bar charts, if we look back here, the width of the bar chart is always going to be equal, and there's always going to be a space between it. All right. A bar chart then is used to represent discrete data. All right. We'll look later on in how we represent continuous data, but for now, that is just representing our discrete data. Okay. So what I want you to have a go at now here is, you can pause the video here and we'll just have a look at some homework. All right. Which would be, what am I looking at here? So exercise 13.1, questions 1 to 7, sorry, not 11, 1 to 7. All right, so that's your first homework there, all based on either bar or line plots. Okay, good luck with that. Okay, so now we're on to our next section here, which is all to do with pie charts. All right, pie chart, one of the main things to remember about a pie chart is that it is based on a circle. And we need to remember and realize that the degrees in here for the center of a circle is equal to 360 degrees. Okay. Pie charts are very useful in representing a smaller number of data entries. So you can see here, like this one here is split into 5. You know, this is split into 4. Generally kind of probably maybe less than 10 data entries. A pie chart, it's a very visual way of representing our data, and it is useful in determining maybe popularity of one thing or another. So if we look at, we'll say this pie chart here, so imagine these were favorite sports. All right, so this could be Gaelic football, this could be basketball. All right, maybe tennis is a bit in the smaller wedge here in that it's maybe not as popular, and then I don't know, you could have hurling or something as well. So it's a nice visual way to straight away kind of make a couple of assertions, you know, maybe most favourite, least favourite, that sort of thing. What can we be asked? Right, you might be given a number of divisions in it, but you mightn't be given the degrees for them all. You might be missing 1, potentially you might be missing 2. But if you're missing, say, the degrees here for your hockey, you need to realize, well, the whole thing adds up to 360. So I'm simply going to add up my 4 remaining degrees, whatever that is, subtract it from 360, and that would be your remainder. Okay, so that is one thing that you might have to do. Or you might be given a diagram and you might be asked, well, how many people were surveyed? Okay, and you might be told the number that, well, we'll take tennis, the number that represents tennis might be 15 people. And you would have to use that fact that you know that for 90 degrees is equal to 15 people, you would have to work out the overall. All right, well, you know that 90 degrees in terms of 360 is a quarter. So multiplying your 15 people by 4, you would get, 60 people is the whole thing. All right, and then obviously you get what 60 degrees, so you'd have to work out, well, what percentage of the whole is netball. It's a sixth, so if there's 60 people in total, the netball would account for 10 people, and so on and so forth. All right, that's the 2 main things that we can be asked in terms of pie charts. All right, there's a couple of examples there, so I would, I'm not going to go through them. I would suggest you either pause this if you don't have a book, if you're just watching the video on its own, or if you have your book, work through the 2 examples there and have a look then at a couple of the questions. So if we just take this first one down here, for example here, 120 degrees plus 90 plus 45 find the value of x. All right, well, if I add these three values together, so I'm going to get 210 and 245. 245, well, if we just, here we'll bring it over into the, all right, so we've already added all these up here. So for this one coming down here, so we have 120 degrees, we're adding on 90 degrees, and we're adding on 45 degrees. And what did we say that was? 190, 210, 255 degrees. Well, if we know the whole thing has to equal 360 degrees, well, if we subtract our 255 degrees, then we're left with 105 degrees. All right, so this value x is equal to 105. All right, and it'll be the same thing in here for both these two. Okay, so again, that's a very basic question, but there it is anyways. If we move on and have a look, any of these a nice one to do. We'll have a look at question 5. All right, so shift, control, and S. These are nice. I think these are a nice question in respect because they are very visual, and it is easy kind of to work out stuff when it is nice and visual for us there. Okay, so the pie chart, the pie chart shows how the cost of a holiday was shared between various items. So we have flights, we have food, spending money, and the hotel. The flights cost 450 euros. Calculate the total cost of the holiday. And then part 2, there's A and B in it. Calculate the size of the angle which represents the cost of the hotel, and calculate then the cost of the hotel. Okay, flights. That's represented of 90 degrees. Okay, so they're costing, 450. So the flights cost the 450 euros. And in terms of our pie chart, that is equal to 90 degrees. Well, what percentage or what fraction of the overall pie chart is 90? Now it's clear to see that it's a quarter, but if it was some other value, okay, so if it was 52 degrees, it mightn't be maybe as obvious. So how do I get my percentage? I put the value that I'm talking about, so in this case 90, all over the total, which is 360 degrees. So that will be equal to a quarter, which is equal to 25%. All right. If 450 euros is equal to 25% or equal to a quarter, I need to multiply that 450 by 4 to get 4/4. All right, so I'm going to have 450 euros, multiply that by 4, all right, and 9, that's going to be giving us 1,800 euros. So the overall holiday cost 1,800 euros. All right. Part 2. So we'll just maybe change color here. So calculate the size of the angle which represents the cost of the hotel. Right. Well, I know that the whole thing has to add to 360. So I'm going to add, well, I have 90 here and 90 here and 60 here. So these are all degrees as well. So we've got 180, 240 degrees. If the overall is equal to 360 degrees, we have 240 of those degrees accounted for. Well, subtracting one from the other, I'm going to get 120 degrees. So the hotel here is equal to 120 degrees. Right, so that's your hotel. Now, calculate the cost of the hotel. So again, we might change up colours again. So, what percentage is 120 degrees out of our 360? Well, 120 degrees all over 360 degrees is a third. All right. So the hotel cost in terms of percentage wise or fraction, a third of the overall price. All right. So if the overall trip and holiday cost 1,800, well, what is a third of that? So all I'm going to do is my 1,800 and divide that by 3. So 3 into that would go 600 times. So the overall cost of the hotel is 600 euros. All right. And that is kind of the height of sort of the difficulty that you might face in a question like this. You're given the value of one slice of this pie, all right? So it's a pie chart, we're calling it one slice. You're given the value in terms of, in this case, money. You're also given the degrees so that you're able to work out, well, what percent is that pie of the overall, and you're able to use that to work out the whole. All right, so it's really important that you're comfortable and happy with using one slice of the pie to work out the whole. All right, then you might be asked again, as we are, other values of different slices of the pie in terms of cost of the trip. Okay, so I would maybe go back, rewind to the start of that, just have another listen or watch through it there so that you're 100% happy with that. All right, and that's really all that we need to worry about pie charts. The other thing is in terms of drawing a pie chart ourselves. So now there's nothing here in terms of drawing a pie chart ourselves, so I'm just going to do it from scratch here. Generally, drawing your pie chart comes up more in your junior cert exam questions rather than questions in your book. So what you're going to need is a compass to draw a perfect circle. So imagine that now is a perfect circle. All right, you need to identify the center point. So there you have a circle. Okay, and with a straight edge, right, I'm simply going to if I hit shift here, draw a straight line there on that. All right, now that's the starting point. So say, imagine that this was split up into 3. So we had 3 sports. So, all right, so we'll say basketball, football, and I don't know what, tennis. All right, so we have 3 sports. This is equal to a third. We'll just say they're all a third. All right. And in terms of the angle, that's going to equal, each of them, it'll be 120 degrees. Now I might do a little video of me actually doing this out by hand, if I might be able to put my hands on a visualizer. So what you would do here is, so perfect circle drawn with a compass. The other tool you need is a protractor for measuring your angles. So what we're going to do is I'm going to now imagine, now obviously this is me sketching, right? But imagine here now we're putting on a protractor, right? The center point of my protractor goes directly on top of the center point of your circle. You line it up then with the line that you've drawn in here, this blue line here, you line that line up with 0 for your protractor. And from here then I'm going to measure out to 120 degrees. And from that then I'm going to draw, I'll go for a different color again, I'm going to draw a straight line from the center point going through the mark on my protractor that represents the 120 degrees, and I'm going to draw that in there. I then lift my protractor, keeping the center point on the center of the circle, now line the 0 up with this purple line here that we have, and I'm going to put on and measure my second angle, which is also 120 degrees. It could be anything else, and we'll put it on out here, and the one that's left will also be 120. So that's how, now again, this is very rough and ready in terms of a sketch, but that's how you'd actually draw and divide up a pie chart of your own. All right, so you need to work out the angles that you need to draw the pie chart into. You need your compass and you need a protractor. Okay, so again, what can you be asked in terms of a pie chart? You have been given the pie chart and asked to work out stuff based on it, or you can be given information and asked to represent that on a pie chart. Okay, so that's all to do with pie charts. And for homework, sorry, I'll just, before you go, put it a little bit in yellow. So if we'll have a look then at exercise 13.2, I will have a look at then questions 1 to 11. All right, so that's your homework there. So pause the video here now and go ahead and do those. Okay, so the next section that we're going to have a look on after our pie charts is what we call a histogram. Okay, and if we just look forward and get a visual representation of a histogram, we can see it's very, very similar to our bar charts that we had a look at earlier. One difference is that instead of having a gap between each of these bars, they're right up tight to each other, so there is no gap whatsoever. All right. The second thing to remember is that the value on your x-axis, all right, it's a range. So any value that would find itself in here, the frequency in here, is going from 0 all the way up to 5, and this is minutes. So any value that will fall in the 0 to 5 minute category is in here. Any value that will fall in the 5 to 10 minute category is in here, and so on. So this is representing a range. Okay, so as we had it up in here. So when we're talking about the frequency, we're talking about the frequency in respect of a range of values. Okay, when we're talking about frequency and ranges, we're talking about continuous data. All right, so if we'll have a look back here, you can see here we're talking about histograms are used to show continuous data. All right, as we had to look at back when we were looking at our frequency tables, all right, we realized that the various divisions in a grouped frequency table were called classes. All right, and it's important to remember that each of our classes will have an equal width. All right, so in terms of time here, each one of these represents 5 minutes. So you'll never have a fact that this will be 5 minutes, this will be 15 minutes, this will be back down to 7 minutes, this will be up to 20 minutes. All right, they're all of equal width, so they all represent the same interval. Okay, but other than that, everything nearly is the exact same in terms of our bar chart. So if we just have a look at, is there any of these that are of particular interest? Look, we'll just pick and we'll do question 4. Again, there's examples in the book. You can have a read of the examples, but I'll just go through question 4 with you now here. Okay, so the histogram below shows the time taken by a group of students to solve a problem. How many students were in the group? Write down the modal class, and what percentage of students took between 20 seconds and 30 seconds to solve the problem. So we'll just look at those 3 first, and then we'll come on to the last 2. So how many students were in the group? Well, if we look at our axes, so the time is going along our x-axis. So it's going from 0 seconds all the way up to 60 seconds. The number of students is along our y-axis. So all I'm going to do is count the frequency for each one of these classes in here. So we've got 1 and 3, we're up to 11. 11 and 12 is, what is that, 23, 23, 29, 29 and 3 is 32. So there's a total here, so for part 1, there's a total of 32 students. So we're just counting the frequency that each occurs. Write down the modal class. Again, modal class is the class with the highest frequency. And we can see in here that the modal class, the highest frequency of 12 students, is the 30 to 40 second class here. Okay, the third one then is asking us something about a percentage, wasn't it? Yeah, what percentage of students took between 20 and 30 seconds? Well, between 20 and 30 seconds here, there was 8 students. All right, so there's 8 students out of a total of 32. Okay, so we're looking at the frequency that occurs here all over the overall number of students in the class. And that will be okay, so percentage 25%. Okay, 4 and 5, what is the greatest number of students who could have solved the problem in less than 35 seconds? And if a student is selected at random, what is the probability that that student took longer than 40 seconds? So what is the greatest number of students? So the greatest number of students, we'll just underline that. So the greatest number of students who could have solved the problem in less than 35 seconds. Right, we know these for definite solved it in less than 10 seconds. These solved it in less than 20 seconds. The students in between 20 and 30 also are below the 30, so these all solved it in less than 30 seconds. Now, this modal class, with the highest frequency of 30 to 40 students, all right, of 12 of them, potentially, all right, remember what we said before in terms of a group frequency table, one of the downsides of it is its inaccuracy in being able to exactly say where the 12 students fell in this range. Okay, so we could assume that every one of those 12 students solved that question in 32 seconds or 31 or 33, as long as it's less than 35. So we can assume that they all are at the lower end of the range rather than the higher end. So in that case, that's going to give us the greatest number of them. So we're going to have 12 and 8 is 20 and 2 and 1. So we're going to have a total of, not sure what am I doing here, for IV. So total number is 23 students max. All right, part 5 then is equal to, if a student is selected at random, so any one of the 32 students picked out at random, what is the probability that that student took longer than 40 seconds? Well, from 40 up to 60 is the range that we're looking at. So how many students fell in that category? Well, there was 6 and 3 is 9. So there's a total of 9 students that took longer than 40 seconds. How do we get probability? So 9 all over 32. All right, and we're just going to take and work out what that is equal to. I'll just get my calculator. So that's working out at 0.28125. Okay, so that's close enough there to 28%. Okay, to the nearest percent. All right, so what percentage? Pick a student at random that they took longer than 40 seconds. Well, it is 28%. Okay, again, you can be given a histogram and asked to work off data that's given to you, or as the likes of question 8 here on the next page, you would have to draw a histogram to represent data. Okay, so making sure that if we look at any of the histograms you've been dealing with, making sure that the width of each class is equal and that your graph here, your x and y axis, is also equal. All right, now they don't have to be equal to each other, they just have to be equal to themselves. Okay, so see here, 0 to 10 is 2 boxes, but 0 to 2 is only 1. So as long as all your verticals on your y-axis are equal in width, and also you're equal in width along your x-axis, that's the main thing. Okay, so homework then, based on those, is if we look at changing color here, looking at our exercise 13.3, and we'll have a look at questions 1 to 8. And I've already question 4 done for you there. Okay, so pause the video now, go ahead and do those, and looking back over this, or in terms of your exam, or example, should I say, in the book. All right, good luck. Okay, so the next section we're going to have a look at here is what we call a stem and leaf plot. All right, they're generally useful for displaying numerical data, and it's useful in a way that the data, we have to have it ordered. Okay, so it's useful for kind of giving an overall sense of the shape of the data. So if we imagine, say, a test, all right, so if we imagine, you know, percentage from 0 to 100, and if we had, you know, 15, 20 students in the class, and we wanted to look at, well, what kind of shape is the data for the performance of the students in the class, a stem and leaf plot is quite a nice visual representation of the data. And if you look down here, this is an example here of a stem and leaf plot, or a stem and leaf diagram. One thing to be aware is you will always be given a key. Okay, so I might just copy this and bring it in for us. So the key is always going to allow us to work with our data and realize what does it actually represent. Okay, so if we have a look in here, the key here, so I'll just do it off to the side, and anytime we are actually creating a stem and leaf plot, we have to also put in and include our key, so that somebody coming along looking at it realizes what it is. All right, so changing color just here. So this is what we refer to as your stem. Give it a little arrow, and then putting the leaf in green. All right, so in terms of your stem and leaf diagram, all right, you can see here we've got a solid line coming down here, and that is going to divide the stem, which are these numbers here. So this is all here, your stem, and then each one of these out here is your leaf. All right, so in this case, the key here is the stem is in tens of units, and then this is just your units. So if we took here this 4 and a 1, that 4 represents 40, or 4 tens. So 4 tens is 40, and then the 1 is 1. So this here is 41. This one here is 42, 46, 53, and so on. All right. If we look at how the data may be given, we might be asked to take and compile a stem and leaf diagram. So this is the data that we have to enter into it. All right, you can see that it's not ordered. So the first thing we would like to do is we would rewrite that data out, starting from smallest to biggest. Okay, oh, it actually is ordered first. Yeah. Okay, so lucky, that's a job less for us. So it is ordered. If we look up here at the 0 for the 6 and the 9, all right, 0 is there's no tens, right, and there's just a 6. So that represents this data entry here, the 6. The 0 and 9 is just 9, represents 9. The 1 is 110, so 10 and 2 is 12, 10, 5 is 15, and the 17 there. So that's how you basically read a stem and leaf plot. Okay, and if we have a look at, say, some of the examples, again, there's an example there, so I'd urge you to pause this video now, have a read through it, or indeed read through it in your book yourselves. So I'm not going to take time doing that. Back to back stem and leaf plots, all right? This is just a higher pitch at it again, but it's simply where we have the stem centered and we have a leaf on either side. And generally where we use double, or what we call back-to-back stem and leaf plots, is when we want to compare a similar, so say we want to compare a class. So imagine our class in school, we start a new topic, we give you a test at the start of that topic, all right, without teaching you at all. What result do you get? We now go ahead and we have a week or two of teaching on that topic. We give you another exam. Is there a difference now between the results before and after you've been taught the topic? It may be a case of, if we took, say, imagine a PE class. So we took the heart rate of all the students at the rest and heart rate at the start of the class. We then allowed you to rest after the class, and we took your heart rate at the end. Is there an increase or a decrease? Or it might be, say, blood pressure in terms of patients. So this is the blood pressure before patients have received treatment. This is after they've received treatment. So you're comparing one thing to another, but you're comparing the same population that you're looking at. So it'll be the same class, the same whatever it is. Okay, so if we just have a look at one or two of these questions, so we'll pick some of these here. So we might I'll do question 3 here for you. So I'll just get rid of all of this. Right, and Control and V, and run that up there. Right, so the number of points scored per match by the Dragons basketball team are shown below. And these are the points here. Copy and complete the stem and leaf plot on the right. All right, so we're going to copy and complete that, and we're in green. All right, well actually I might, a nice straight line maybe. So again, when you'd be doing this, you'd be doing it nice and accurate in your copies with a ruler and so forth. And we'll put in the right and maybe blue. All right, so if I look at the data here, all right, I want to look at, well, what's my lowest score and what's my highest score? So we're 85, 99 is the highest. So 99, yeah, I'm sure there is the highest, and the lowest in the 50s, 49. So the lowest is a 49 and the highest is a 99. All right, so our stem goes from 4 all the way up to 9. Okay, so the lowest score all the way up to the highest, and we'll put that in here now. So there's my stem. All right, and these are the leaves. All right, so again, try and start out from lowest. So we have a 49, so I'm going to cross that out here, and I'm going to put in a 9 here to make a 4 and a 9, a 49. There's nothing else in the 4s, so now we're going into our 50s. So we have a 53 and a 56 and a 59. Okay, so we have a 53, a 56 and a 59. All right, so crossing those out, a 53, our 56 and our 59. All right, now going on to our 60s. So we have a 66, a 67, a 69 and a 65. So again, we want to know this has to be ordered from lowest to biggest. So what is the smallest here? Well, we have a 66, 67, 69, 65. So 65 is the lowest. So 65. All right, cross that one out. We have a 66 and a 67. So our 66 is counted for, our 67 is counted for, our 69, we're going to add that in. All right, so crossing out our 69, I've it already crossed out. Okay, now we're on to our 70s, so 73, 72, so a 72, and a 73. And we've also actually, I see there, 78. Have we any others in the 70s that we might have missed? No. So 78. 78 there, right? And now in the 80s, so we have an 85, an 84, and an 81. So we have an 81, 81, 84, and 85. So 81, 84, and 80, sugar, that should be 85. So crossing those out, our 81, our 85, and our 84. We also now have an 88 and an 89. 88 and an 89, so 88 and 89, and crossing those, then we have a 92, 97 and 99, so 92, 97 and 99, and crossing those out. Where's our 92 there? Now look, we actually also have another 97. So adding in a 97 in here. So I'll just rub out this 9 and put in another 7 before that 9. So a good advice here is to make sure you're doing this in pencil so that you can rub out if you don't leave enough space here. So part 1, all right, it's a little bit slow, it's a little bit tedious, but it's not hard. There's nothing complicated about it. You're just realizing your stem and your leaf. Main important thing to put in here now, and we'll put it back into green so that it stands out, is your key. So we need to identify the key. What does this mean? What is the data that we've just done? All right, so if I say look at the 4 and the 9, so the 4 there, well actually we'll do it in color. All right, so the key here is, I'll keep that green bar there and go back to our blue. So our 4 here and our 9 here, and that all equals 49. All right, so the 4 and the 9 equals 49, so that the people, when they're reading that, they realize, well, these are tens and they're not hundreds or thousands or whatever. Okay, so that's our stem and leaf plot filled in. Write down the range of the scores. Well, the ranges, what do we mean by range? It is the difference in the lowest and the highest, right? Well, the highest score for, so that was part, oh sorry, undo that. Sorry, so this was just, we had just had to copy and complete that, all right? So question 1 then based on it, the range, well, the highest score is 99. We're subtracting away from the lowest, which is a 49, and you're going to get the range of 50. Okay, so on to now part 2, finding the median score. So median is our middle score. How many scores have we got in here? So we want to look at, well, how many games is there? So if we count all of these up, we'll find that there is 20 entries here, so they have played 20 games. All right, so our median, if we want to find the middle position, sorry, I don't know, go back to orange. So if we want to find the median number position, all right, if we think back to our n plus 1 divided by 2, well, if n is 20 plus 1 divided by 2, that's going to give us 21 divided by 2, so 10.5 position. So it is an average, if we're going to get here, of the 10th and the 11th value here. So we're going to add the two of those and divide by 2, okay, to work out the median here. So if we look at, well, what number is in the 10th position, what number is in the 11th position? So 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th and 11th. So if I'm looking between these two scores here, all right, so I'm going to add 73 and 78 together. And then divide by 2. So 140, 151, and that's going to be 75.5 was the median score scored in the matches. Now, I'm going to show you another way to do that, just in case you forgot how to work out the position of the median value doing the n+1 divided by 2. So if we just copy this here, and bring it out to the side. All right, so altogether less sophisticated. I'm just going to start from either end of my data and start crossing out. Now you could do this and just covering the numbers with your fingers, or a light pencil if you have it in your copy. So I'm crossing out from on this end here from the highest down, and from this end here from the lowest up, making sure that you're going the next lowest number here from 92 will be the 89, the next highest number from 59 will be 65. So I'm just crossing from lowest to, and you can see here the next number that I would cross out from the lower end would be my 72, the next number that I would cross out from the higher end coming down will be 78, but if I cross those two numbers out, I'm left with no number in the middle. So when I have an even number, all right, I'm going to have to look out and get the mean of these exactly as you've done all over here. So you're adding your 73 and your 78, dividing that by 2, and you would work out the median that way. So this is using its position value, realizing the n+1 all over 2. Here is altogether more straightforward in that you're simply crossing out from either end until you meet in the middle. All right, so either way works perfect. As long as you get the correct answer, you're spot on. Part 3. So in what percentage of matches was the number of points scored greater than 80? So what percentage, right? Well, we have worked out that there's a total of 20 games. So we'll stick to the purple. So there's 20 games in total, all right. What percentage of matches was the score greater than 80? Well, if we look at down here, right, 81 and every number after it was higher than our 80. So we have 5 matches there and we have 4 matches here. So we have 9 games in total where the score was higher than 80. So percentage-wise, it's going to be our 9 all over our 20, and just dividing that with our calculators here, 9 divided by our 20 is 0.45, which is 45%. All right, so to fill in a stem and leaf plot, it is a little slow, it's a little cumbersome, but it's not hard. The only area where you may go wrong is pulling out figures, in such case the median value, the middle value. So you can realize n+1 all over 2 will give you its position, or simply cross out from both ends and arrive at the middle. Okay. And as I said, then the next section is your back-to-back stem and leaf plots, which again, there's nothing of any extra trickiness in it. It's just maybe a little bit longer, all right, but it's the exact same principle. So for homework there, if we go back to here, we'll put it out in yellow again, stay consistent. So the first section I want you to do, 13.4, we're going to have a look here at question 1 to 6, and they're just single stem and leaf plots, so they're not the back-to-back. Then what I want you to go on the following day, so this is 2 days work here, is questions 7 to 12, right? So if you want, you can go from 1 to 12, but I would advise you break it down into 2 days so that you're coming back to stem and leaf plots rather than firing all through this and maybe not allowing it to soak in and learn it as best you can. Okay, so again, pause that video and you go off and start doing the first section there of your exercises. Okay, and the last section out of this chapter that we're just going to have a look at is something we call misleading graphs. All right, so you might be given a graph as such as maybe this bottom one here in terms of the sales of two particular brands of dog food. Now, if you were to look off that straight off the bat, you might say, well, hey, Munchies is twice as high a seller as Doggos. All right, but what you'll fail to realize is that this graph does not start at zero. So this might be 120 and 140 euros, all right, or units sold. Maybe, yeah, we'll stick with the units sold. So Doggos has sold 120 units, whereas Munchies has sold 140 units, all right. So if I just bring this into that we can work with it. All right, so we'll imagine, so before we go doing the actual figures, imagine, right, from what we can just looking at the graph, that looks like that, so I'm just going to call this 1 and this is 2. All right, well, it's actually hard to see those go purple. So number 1 and number 2. All right, so we can just see that the sales for units number 2 is twice that of number 1. All right, so number 2 here sells twice the amount as number 1 here, so Munchies and Doggos. If we actually take an account of the axis here, well, there's actually number 2 has sold, right, 140 units. Number 1 has sold 120 units. So the difference really here in these two is only 20 units, all right? So if we look at, well, what is 20 units in respect to the overall? Well, the overall is 140, so all right, and that is going to give us what percentage? 14%. All right, so from this graph here, it looked like this was plus 50%. All right, so this was doing 50% better than our Doggos. Actually, here, I'm going to start all over again. That's all completely clear on. Okay, so as we were saying, we can work with this now. So from this graph, it looks like Doggos is selling half the amount that Munchies is. All right, so in terms of percentage wise, how much better is Munchies compared to Doggos? Well, it looks like Munchies is 100% better, all right, than Doggos. All right, so if this is, what Doggos are selling, well, these are selling twice the amount. So they're selling 100 times more than what Doggos are selling. Or these are selling 50% of what Munchies are selling. But if we look at the actual axis here, the difference is only 20 units. All right, so Doggos, D for short, is selling 120 units. Munchies, M for short, is selling 140 units. So the difference here is only 20 units between the two companies. All right. And in terms, what is 20 units out of 140 units sold? Well, divided by your 140, that's only going to be 14%. So in actual facts, Munchies are only selling 14% more than Doggos. But this graph is misleading in that because it doesn't start at 0 here, all right, it appears that Munchies is selling 100% more than Doggos. All right, so they're selling what Doggos is selling plus that again. So they're selling double what Doggos are selling as it appears there. But in actual fact, they're only selling 14% more. All right. If we go back here as well, if there is no access given in, all right, that can also lead to a misleading graph. Okay, so this is all about misleading graphs here. If we look at the next page here, again, they're still on about Doggos and Munchies, right? The width of the bar for Doggos is half the width of the bar for Munchies. So again, if we're talking about area, right, the area has to be the same, all right? Now, in leaving cert and in third level, you can have plots and diagrams where the area it isn't exactly the same. It can be relative, but for us here, always, the width of our bars have to be the same. And just because it's represented by the figure of dog here doesn't mean anything, okay? Also, how else can we have what facts do we need that we have to sustain to make sure that the graph is as accurate as possible? Well, the width has to be equal. Our graph has to start with 0 and it has to have your scale included in there. So you can see here, this is the actual representation of the two companies, and you can see there, as we worked it out, that Munchies is only selling 14% more than Doggos, whereas if the previous diagram here, it would appear that they're selling half of what Munchies are. All right, so that's just a thing to point out in terms of misleading graphs, and there's a couple of questions there to work through in terms of misleading graphs, and then there's a few exercises there on your test yourselves. Okay, so how many questions have we on in this? 12. So for the last section of this, in terms of our homework, we're just going to have a look at the test yourself. And do questions 1 to 12, the odd ones, plus then that section on the misleading graphs, which is 13.5, our exercise. 13.5 questions 1 to 7. And just double check that there's 1 to 7 on it. One to 5, even less V sound. Right, so okay, so that's the last section of homework, and that's the finishing up on that chapter as well. There's a good few examples in this video here, but make sure you send me a message there if there's any you would like me to go over and discuss with you. Okay, so that'll be the wrap up of our statistics, bar doing some of the exam paper questions. Okay, take care, good luck.